Okay, welcome to OneQuantum Africa weekly meetings. Thank you very much, everyone, for joining us. I know today we may have stretched most of you late into the evening, but there were circumstances beyond our control, and to make this work, we needed to, to shift our time. But all the same, I think for many of us as well in Africa, it's maybe a better time because during the day we are busy at work. So let's see whether this works out. We may need perhaps to discuss about which time zone and which time rather it works for most of us, and perhaps fix our meetings mainly there. This is more iterative, so I'm always trying to reach out and find out what works best for the community. So feel free to reach out to me and let's discuss the best time that we can host these meetings as well. So today we have got Professor Ahmed Younes from Alexandria University in Egypt. He's going to help us around the discussion on how to move quantum forward in Africa, looking at the opportunities and challenges around this topic from an African perspective. Let me share a bit about why quantum is important in Africa from where I stand. So this is more of a lot of text. Don't worry about the busy slide, but what I'm simply trying to communicate is that when I look at my history as a teacher, I realize that some of these subjects, you don't have to do them because you want to build a serious career around them. What we need right now is, well, for people who are interested and active in quantum, obviously we want them to understand how they can harness that curiosity to build something that, that is impactful and that has got meaning in their lives. And also allow them to just pursue that as a passion for as long as they, for as long as they want to. Further, the reason why we need a community like this one is we want to provide a safe space, which is welcoming and where we, have conversations without, upfront expectations on who you are and, what are you bringing to the table, because everyone has got something to contribute. So whether you want to take this beyond the enthusiast level or you just want to stay abreast with the developments in technology around you, this is a place where you should feel you belong. Beyond that, we want to build a platform or a community where we allow, or we've got this framework which allows people to get exposed into the expertise that is around in the field, so that for those who want to be serious, to build serious careers in the space, they've got an opportunity of taking these discussions and this knowledge further. But for the best case, it's just to make people confident citizens in a technological world that is being shaped by technology. So after all is said and done, if ever we are going to achieve anything in these discussions, then it should be to bring together people who are in different roles in society to come and discuss how to move quantum forward, especially in Africa, and discuss around issues to do with the social consequences, economic, technological, ethical, cultural influences of quantum technologies in our communities and in our society, and also appreciate the benefits and the detrimental effects of this technology to our society, so that we shape it in a way that works the best, in a way that creates impact, that creates positive impact in around us in terms of at an individual level, as a community, and as well as environmental impact as well. So let me tell you briefly how we try to achieve this at OneQuantum. Excuse me. So OneQuantum has got 4 pillars where we are building communities, which is we have got strong local communities that we connect with the global community. We also provide mentoring, which allows people to develop professionally in quantum tech. We also have got a career aspect where we receive CVs from our community members. We work with what we call our career partners to create tangible opportunities for people from the continent. In other words, for employment, internship, postdocs, and any other opportunities that may be available in the space. Then finally, we work on projects. So we want people in the continent to work on projects that are relevant to their communities, or as a continent to work on problems that are relevant to our communities and to our society broadly. I have to thank you all, to thank all of you and thank the global community for the wonderful support that we got for the OneQuantum Africa Summit, the first one that we hosted on May 12 and 13. Many thanks to the sponsors that made this possible. Honeywell being the lead sponsor, it was at short notice, but those guys came through to us and said, well, you want to host a summit in Africa, we're going to be behind you. And we may not have enough time to put everything else in place, even bring you a keynote speaker because it's short notice and our time zone is not, does not agree with yours, but we are going to be happy to support this effort. And we really thank them very much. As well as the Unitary Fund, who were our early sponsors. The first time that we talked about the summit, they came through and said, well, we like this. We think it's something that we want to help you to make sure that you deliver this and becomes a success. And they came through for us. Bayete Quantum Technologies, one of the startups, if not the only startup from Africa, that stepped forward to put skin in the game and to say, no, we can't have international partners only. We also need to put skin in the game from Africa. So we thank the guys from Bayete Quantum Tech very much. QRisk, Oxford Instruments, Code Quanta, TechnaSearch, AeroQ, and individuals as well as volunteers who put their effort behind this idea and helped us in many ways and amazing ways to make sure that word went around. We had posters and everything else came together for the summit to be a success. So I couldn't proceed without thanking all these people, including our speakers who took time away from their busy schedules to be with us, as well as the attendees, obviously, who made this very successful, made it fun, were very active, engaging. We had the cocktail, we networked with the broader community, and we had beautiful conversations there. So I want to thank you very much for this. I also wanted to just share that what we do with the CVs that we receive from the continent is we are creating a job portal and a database of resumes that we're working together with career fair partners to give exposure to talent from the continent, as well as to learn about what could be the gaps in terms of talent development in the continent, because we want to produce people as well who can, contribute to build this field in Africa, but also who are competitive globally. So we are partnering with the career fair partners there to learn about how best we can help to improve the talent in the continent. And we are open to receive CVs from you guys. Feel free to send CVs to brook@onequantum.org, and we will make them part of this database. And we will receive feedback on how best you can optimize for a career in quantum tech. And it also helps even the mentors that we work with to learn more about you so that they can support you. They can support you more in your journey as you develop skills and move forward in this field. These are our chapters: OneQuantum Africa, which is where we are at. OneQuantum Startups. For those that have startups, you're free to talk to me more about the OneQuantum Startup chapter. Women in Quantum, which may be the more popular one, which has been giving us wonderful summits and content for the past almost a year. And recently we welcomed OneQuantum Nepal. We've got OneQuantum India coming. We've got another chapter from South America coming. And so those are exciting things. Building a bigger network for our community in Africa to interact with and to learn from. Some of you may be aware that our quantum chapter in Nepal, Manish is doing a very good job there, delivering content. If you want to learn more about the actual hands-on knowledge in quantum tech, feel free to check out their content, really technical and is, you know, top deck, and it's something that you may want to follow if you are working seriously in developing your capabilities in the technical capabilities in the space. Let's connect and keep this conversation moving forward. I'm available on these different platforms, and these are my contacts. And let me now introduce our speaker today, who's been working very hard to build quantum in Africa and in Egypt as well. So Professor Ahmed Younes is a professor of quantum computing at Alexandria University, and he is a leader at the Alexandria Quantum Computing Group. So this is his bio. He has been a teaching assistant in the Faculty of Science, Mathematics Department, 2002, research student and teaching assistant at the School of Computer Science at the University of Birmingham in the United Kingdom. He's been assistant professor of computer science, the Faculty of Science, Computer Science and Maths at Alexandria University in Alexandria in Egypt. Also full professor now of computer science at the Alexandria University, Alexandria in Egypt. Let me introduce our speaker next week. We are going to hear from Alexandra Priyutov, who is a business development manager at QRET in Russia. So we try to reach out broadly so that we learn about about quantum technologies from different communities. And this is something that you don't want to miss. They've got a lot of opportunities for collaboration, and is going to come through and share those with us. I think this is my last slide. I'll stop sharing and allow Professor Ahmed Younes to come forward and share with us what he has prepared. I know he had a busy day, so if you see that he's a bit tired, please bear with me. I'm the one who stretched him to accept to still do this today.
Right, so try to keep me awake.
We'll make you wake up.
Thank you, thank you, Farai, very much for this introduction, and thanks for the invitation. I'd like to share my screen.
Yes, you can. You can go ahead and share your screen. I think that should be able to happen.
So, can you see my screen now?
Yes, I can see your screen, Prof.
Okay. Hello, everyone. Good evening. Today, maybe we can discuss how we can make quantum computing move forward in Africa. Let me start quickly with the usual start in any quantum computing talk. What is quantum computing? Why quantum computing? Why it is a must now? Let's start briefly without details. No background is required in the talk. Let's see why we are in the stage or in the age of quantum computing now. To understand this, actually, we have to understand how classical computer, the one we are using right now, came to life. Actually, it came to life in 1947 when they invented the transistors and to build new families of computers to increase the capabilities of the computers. You have to increase the number of transistors in the microprocessor, but they have a constraint, a commercial constraint, that the processor should be on the same physical space. So they had to decrease the size of the transistors to fit more components on the same physical space using technology called miniaturization. But actually, one of the founders of Intel notes that the number of transistors per square inch on integrated circuit is doubling actually every year. So the transistors are becoming smaller and the number is increasing. And he put this law, which is just a note, but it turns out to be true till today. But this miniaturization, we can notice in any electronic device you use. For example, in 1 year, for example, if you have these two transistors in a certain physical space, After 1 year, the number will be doubled on the same physical space, so the transistor will become smaller and smaller and smaller and so on. So how far can we go in this miniaturization process? You can actually notice this in any electronic device we use today, that the size is becoming always much more powerful and smaller at the same time. And this is just to show you how the number of transistors increase in every generation of Intel microprocessor, for example. So the number is increasing every year, approximately every year. But actually, these laws say that we will reach to a size of a transistor where we cannot make it smaller. Actually, when it reaches the atomic level, so according to Moore's law, the number of atoms per bit will reach actually 1 atom per bit in 2020. If you follow the progress in the development of microprocessors, you will realize that actually Intel, for example, didn't make any new CPUs since 2005, I think, where the last one was Pentium 4. After that, they couldn't make any new processor, because actually making processor smaller, making transistor smaller will make them lose the control over the transistor, these charging zeros and ones things. That's why they couldn't make any new families. What they are selling now is all the processors integrated together somehow. So we know dual core, for example, these two old processors integrated together, or quad core, or octa core, or hexa core. These are all old processor integrated somehow together, not a new processor as usual. So we are facing a challenge now since maybe 2007, 2005. That the development in computers are almost done. We cannot make it any faster. We cannot make it any powerful. So we have two choices: to stop development in the field of computer, which of course we don't want to do this, or we have to find new alternatives to do computing more powerful. Actually, people are trying to find alternatives, but actually quantum computing is one of the biggest winner so far as an alternative. So actually quantum computer is a must. If we didn't go to quantum computing, we will stop development in computer science. And actually, the idea of quantum computer is not that new, because it's first proposed in 1982 in the paper of Richard Feynman, who was trying to do a certain quantum mechanical experiment on classical computer, but actually he fails. He couldn't do the experiment. So he actually published a paper proposing that if actually the computer itself is working with the laws of quantum mechanics, is going to make the computer itself better. But no one actually knows how to use this until 1995, when Peter Shor proposed his algorithm, quantum algorithm, that works only on quantum computer to solve the integer factorization problem. Integer factorization problem is an important problem in computer science because it is hard problem to solve, and because it is hard, actually it is used to encrypt all the online transaction we use today. So for example, if you are using your credit card on any website, so it is encrypted using this HTTPS protocol. This secure protocol relies on the that integer factorization problem is a hard problem. And it means that actually to solve this problem on classical computer, it needs hundreds of years. what actually Shores did using his algorithm is to propose an algorithm using quantum computers. This is a complexity of the Shores algorithm. It means that actually we can solve the problem that takes hundreds and thousands of years on a classical computer in actually a few minutes on a quantum computer. This is the moment that actually people realize that actually, yes, we have a computer that we can use and we can do things much more powerful. So we have now choice to move to quantum computing because if we didn't, we will not do any progress in using the classical computer, and also moving into quantum computing will give us much power in computing than classical computer. This is actually the real start of the field of quantum computing. After that, Love Grover proposed a quantum algorithm that can actually search databases very efficient, faster than classical computers. Using actually these two algorithms, this is the two milestones of quantum computing so far. People realize that what we have a new computer, we have to investigate, we have to know what can we do with it. So immediately after these two algorithms, people are trying to find what can we do with quantum computing. So nowadays you can find people doing quantum computing in all fields of computer science. You can search whatever topic you are interested in computer science and just put the word quantum before it. You will find people are trying to do the quantum correspondence to it. You can find many universities working on this right now. There is a very interesting link I'd like to show you that actually this site is very important, Quantum Computing Report. I don't know if you are aware of it or not, but you can actually find all research groups all over the world over this in this site. Actually, we are lucky that we are here. Egypt is here. I hope we can find more African. South Africa is here. I hope we can find more African countries here. So try to, when you establish your research group, try to register your group over this site. So what's next? People are trying to find what can we do still, what we can do with quantum computing. So they are proposing algorithms to solve problems using quantum computer. It turns out that actually the quantum version of the algorithm is always faster than the classical version. We have speed up, high speed up over classical computers using quantum computer. So people are trying to use quantum computer now, and it's not theoretical anymore. It is not research anymore. Actually, many people are building quantum computers now, real quantum computer, which you can use, which you can buy sometimes in few companies selling quantum computers. But to do this, actually, the physicists are trying to find what quantum system we can use to realize this quantum computer. This slide is from Wikipedia. I didn't try to find somewhere hard to find. Just go and write qubit on Google and check what is this. So actually, the people working in physics find that we can find many technologies to implement the quantum system. Some of them already implemented, some of them are still under investigation, but actually some of them already there in a commercial level. So for example, the superconducting qubits technology are used by IBM, for example, to build a real quantum computer, by Google and by Rigetti from the US. This is computers which you can use now and try build your own quantum algorithm or quantum circuit and find what you can do with it. There is another technology, photonic quantum computers. We have actually two big players in photonic quantum computer. One of them is Xanadu quantum computing and Psi quantum. These are two technologies using photonic. This is another technology, ion traps. We have these companies having a real quantum computer, Honeywell, IonQ, Oxford Ionics, and Sandia Labs. They are using ion traps to build their own quantum computing. So actually, this is very interesting because in the first, people are trying to find which technology can be used to build the quantum computer. It turns out actually many technologies can be used to build the quantum computer. So actually, this is maybe a job itself. So when people try to buy quantum computer in a few years, which technology to use? So we have to have some consultants. This is maybe jobs in quantum computing, to have a consultation over which technology to use, or which one to buy, right? Because actually every technology in this has advantage and disadvantages, weakness and strengths. So we have to do a careful research before buying quantum computer. So you are not going to the market and tell the guy, I want to buy quantum computer. He will ask you which one, superconducting qubits, photonics, ion traps, or adiabatic quantum computing by D-Wave, or topological quantum computing by Microsoft. These are all different physical systems are used to build quantum computers. Actually, we still have more quantum computers in real life now. For example, Intel are working with TU Delft University to build their own quantum computer. Intel are trying to catch with the race because new names are appearing now, building a new quantum microprocessor. Quantum Brilliance are promising to sell a room temperature quantum computer, which you can buy today and use in your home. QTech and the Kilimanjaro quantum computer, these are all real quantum computers which people can use. But actually, we cannot do anything using these computers or using this quantum computer without the programming languages, right? And actually, I just want to show you that quantum cryptography is a new way to encrypt data. And actually, this technology is there for a while. It is the companies working on quantum, the devices, quantum cryptographic devices are there for a while. There are many companies established years ago, which is very interesting that we find companies, but this technology is not there till now in Africa. So people are trying to secure their communication with quantum computing, which is much more secure than classical computer. Sometimes it is unbreakable using some protocols. You cannot intercept the quantum communication for physical reasons I will not explain today, but we have these technologies ready to use. The bad news, which I'm not happy with, that actually quantum technology is not there in Africa till now. Maybe in research labs in very few universities, which can be counted on one hand. But this is not good. We have to work hard to increase the quantum computing technology in Africa. Actually, you'll find many startup companies. Let me show you this in a minute. we have many startup companies. This is the same site. You can check these players. We have private startup companies. Till now, actually, still, I cannot find any country in Africa that has a startup. I think OneQuantum Africa should appear here, should be visible as a consultation and training and helping people to work, because I believe it can be as a company. If Farai can correct me, we have to show that these many startup companies working on quantum computing. This is a private sector. We have actually companies from the public sector as well, and we have companies projects that belong to the governments. But Africa appears only in universities in Egypt and in South Africa, and this is actually not true. Because we have many countries that can be added today, but they have to make the decision to contribute to this. I will show you this in a minute. This is another very interesting slide in a paper published in PLOS ONE in 2018. It shows quantum computing programming languages. We have a new programming language that works on quantum computing. For example, this cascade set, it works on IBM quantum computer. Circ is for Google quantum computer. This comparison shows this paper shows a comparison between these programming languages. It shows the source code documentation, the README file exists or not, the user documents, the tutorials, and things like this, and they sort the programming languages according to this criteria. So we have new computers, we have new programming languages, we have new companies, and this is another very nice slide from Alba Vera. It shows how actually these programming languages works over the quantum computer. So till now, we don't have a high-level programming language. Sometimes this programming language is machine dependent, as if we are using machine language or machine assembly language, for example, in classical computer. So people are trying to find, this is all opportunities which we can contribute. We still have very big chance to contribute, to have our fingerprint in the field, because the field is still in the beginning, still many opportunities to do. I hope we not turn out to be users. We have to contribute is this new technology. This slide shows the quantum computer architecture. People are trying to build quantum computer architecture, which if you are working in computer architecture on classical computer, you will be interested very much in this slide. You will understand how we can actually build this quantum computer. And if you want to switch to quantum computing today from your classical computing specialty, you can find where to start. If you are interested in quantum complexity theory, this is your component, quantum algorithms, system organization. And so, for example, in Alexandria, we are working on this level, quantum complexity theory, quantum algorithms, and quantum programming languages. Some people we have some lake in these specialities, which are related to engineering and physics. People should contribute in this more. So we have almost established field in quantum computing. We can now know what we can do and what we want to do. I'd like to show you very fast what we are doing in Egypt. If you think this is useful, maybe you can do the same or do better, I hope. Let's briefly see what's going on in Africa. So this is a map from Quantiki. Quantiki is one of the biggest portal in quantum information. Every group should register their group in here in this site. Let's focus more. This shows where research groups are distributed all over the world. But when we focus on Africa, it turns out actually we have only two groups registered on this site, one in Egypt and one in South Africa. And this is not true. In a few slides, I will show you that this is not true because in 1 week we can have many groups appear on this screen. Because actually we have countries working on quantum computing in Africa, but they are not contributing. They are not disseminating themselves. They are not registering their groups, and this is not true. So I hope this map may change if you are working on quantum computing in one of the African countries. Please go and register your group, and I'll show you this in a minute, that this slide is not true. But let's see quickly what we are doing in Alexandria Quantum Computing Group in Alexandria University. This group is established in 2014. It's not very old. This is our website. We have cooperation with some universities in Egypt, many universities in Egypt. Actually, we have people working on quantum computing, but not as a group because they are individuals. This is our group. These are master students. These are our postdoctoral students and the faculty. And actually, everyone is working in a certain topic in quantum computing. So this is the topics we are working on as a research in quantum computing. And if you think it is too many, I tell you our policy in Alexandria Quantum Computing Group. For example, I will just show you very quickly. For example, Basma is working in quantum cryptography. Minna is working in quantum machine learning. Khulud is working in quantum circuits. Justina is working on quantum circuits, optimization of quantum circuits. Muhammad Shaban is working on quantum circuit. Myrna is working in merging between DNA computing and quantum computing. Sarah is working on state preparation for which is related to machine learning. Nurhan is working on quantum image processing. Mariam is working on quantum circuits. Doha is working in quantum state discrimination, and Karim El-Safti is working on quantum machine learning. Actually, when master students, for example, come and want to register for their master, I let them choose their specialization. Any field in quantum in computer science. I am not expert in any field in computer science. I can contribute as a quantum. So we always have two supervisors, me as a quantum specialist, and a doctor working on another topic. So we merge computer science, image processing, computer science with quantum, so quantum image processing, and so on. So we are working actually horizontal. We are not focusing on a certain field in quantum computing. That's why you will find that we are working on many different fields. So this is actually helpful because I think the floor is there to contribute in all the fields. We don't have to focus in quantum search algorithms, for example, or in quantum dot stellar automata, for example. We have many fields which we can contribute. Sorry? Someone is speaking? Okay. So so far we have awarded 7 PhDs in quantum computing and 5 MSCs in quantum computing. And actually it comes gradually to have this community, to have this group in Egypt. It first starts with when I finished my PhD in the UK in 2004. I returned to Egypt and I found myself alone. No one works in quantum computing in Egypt. So I try to do seminars to make awareness about quantum computing. After a while, I suggest adding a course in the PhD level, and I got the approval. So I start working with PhD students. They have a full course in the PhD level. After a while, we move to the master level. Now we have two courses, master level and PhD level. And a few past years, maybe 3-4 years ago, we start working with the undergraduate level. So we actually have a postgraduate level, PhD, master, and undergraduate level on quantum computing. It takes time to make all this legal and organize these things. The activities we do in quantum computing, in 2016, we organized one-day conference in quantum computation. In 2019, we organized a summer school in quantum computation, and also another one-day conference in 2019. In 2021, we organized a winter school and workshop. And let me tell you something. Actually, the real beginning of the group is actually from 4 months ago. The group was there for many years, but no one knows us, no one aware what we are doing. But we had this plan 4 months ago, only 4 months ago, and it works very well. So I suggest groups in Africa to do the same. Actually, COVID-19 has many drawbacks, but it actually has advantages as well. Without COVID-19, we will not have these online meetings, right? So we can exploit the current state that people are meeting you online to disseminate our research easier, because developing countries cannot afford always the transportation and the flight cost and the accommodation and things like this. So actually, online meetings helped a lot to disseminate the work of our group in only 4 months. So let me show you what we did in 4 months. We organized this workshop on quantum computing. We invited many scientists. This is Dr. Faisal Shah Khan, Amir Abbas from South Africa. Mr. Farai was with us in the workshop. It's a very interesting talk. Dr. Muhammad Zidan, Dr. Zoltan Zimboras, Dr. Paul Gora, and Thomas Promley, and finally Nick Prone from IBM. We established a website, a Facebook page and LinkedIn page and YouTube channel. These are all only in 4 months. So there is no excuse actually during these circumstances that we are all using internet. So we just need some effort to disseminate the group. We actually in these 4 months we organized, we start to have many connections with many parties. For example, we applied for Q Egypt and we are still waiting for the announcement. We are now represented in World Quantum Day. We have cooperation with Quantum AI. We have cooperation with Tennessee Tech University in the US, where we actually started working with them. They asked us to to start cooperation. We are sending people from our group to their university to get their PhD, and actually we are supervising students over there. We start working on this already. We have a project started, a project with Mississippi State University in the US. We got grants from Academy of Scientific Research and Technology in Egypt. We got grants for 9 projects. So actually, we need to work hard on this, but it's not that hard now because 99% of the work, or maybe 100% of the work, is online. So we have should have a dedicated personnel who are expert, are interested, and believe in the case. And actually, I have to mention our member Karim Safti. He helped a lot in the dissemination. So you only need to have a website, a group, of course, as a first, a website, Facebook page, LinkedIn page, and someone dedicated to do the dissemination. Maybe Karim, I don't know if he is here or not. He can make workshops on how to do this work. Actually, we already established a Center of Excellence for Quantum Computing also in Alexandria University. It's much like a company. It is not an official company, but it can be. It allows us to deal with the public because the center is a research group. Sorry, the group Alexandria Quantum Computing Group is a research group focused on research only. But this Center of Excellence will allow us to deal with the public. So we start to have some sort of a company in Alexandria University that can provide service to the public. We also have a course on the YouTube in Arabic. I believe this is the Arabic course. This is a series of 12 lectures, full lectures on YouTube. We are adding more lectures. So this is very useful to disseminate the quantum computing field using the language of your countries. We also are organizing Alexandria Quantum Computing Hypatia series. Hypatia, if you don't know Hypatia, she is an ancient Alexandrian mathematician from Alexandria. So we invited many researchers. Actually, this is very useful. We are honored to have scientists all over the world presenting in Hypatia. This is very good chance. I'm telling you this story to tell you that we did this with almost zero cost. To organize all these events, to organize all these workshops, to organize, to do all this dissemination using the usual way will cost millions. So actually, it is a very good chance for the developing countries to exploit the COVID-19 to appear, to get connected, to show to the outside world that actually there are very good groups in Africa. We are establishing now a professional master. This is our next plan. To establish a professional master in quantum computing and quantum information. It will be a full master, 36 credits over 1 year. We already submitted this to the legal side in Egypt, and we are waiting for the approval. And this will be, I believe, the first master in Egypt and in the Middle East. I'm not aware if there is master degrees in full master degree in quantum computing in Africa, but it is the first one in Egypt and in the Middle East. So where are we in Africa? Are we that far from the outside world? Let's check these statistics. It shows that actually we have many countries working in quantum computing and already have contributions. These slides are from SciVal. It is a data analytics tool over a Scopus database. Shows that actually this is the top 10 countries working in quantum and reversible circuits, for example. So I chose this topic to analyze which country are working on. So we have Egypt, we have Tunisia, we have South Africa, we have Algeria, we have Cameroon, we have Nigeria. These countries already producing paper. So there are people working on this field in these countries. So this can be organized as a group, right? And they should submit their application to Quantiki, for example, or to Quantum Computing Report to appear as a group. So this Africa does not contain only two groups. We can have many groups actually. This is a countries, but if you check the universities, you'll find many universities. Actually, every university in this slide can have their own research group and appear on the map. So actually, we can do many. We can have many research groups. So please, if you are working on quantum computing in one of the African countries, and please try to establish your own group. And actually, in 4 months, you can be visible to the outside world. We were not visible from 2014 to 2021. And in 4 months, we are here now. We are being invited to give talks, and we invite people to give talks. So this is very important and cost nothing, I think. So we have universities, we have many research groups, many candidate research groups which can be added to the group. These are the authors. We have many authors working on quantum computing. I believe all these authors can have their own groups. Actually, some of my colleagues in Egypt, doctors in Egypt, are asking to join Alexandria Quantum Computer Group. They are not working in Alexandria University, but they are interested to join our group. I tell them, no, please, do your own group. I'll be glad to cooperate. I'll be glad to give hands. But I want the number of groups to increase in Africa, and this is not very hard to do. So instead of joining Alexandria, no, establish your own group, and we can make link. So we have these two points over the map. We have 2 groups, we have 3 groups, we have 4 groups, and you will be visible to the other. It's very easy to do this job. This is another field in quantum computing. I was just checking some of the fields, quantum algorithms, especially quantum algorithms. So we have completely different groups working in quantum algorithm. All these groups can have their own group, and we can increase the number of groups in Africa very easy, because we already have people working, we already have universities working in quantum computing. So that's why the map I showed you of Africa that contains only 2 points is not true. We can have 10 or 15 points in 1 week if people decide to organize themselves and do work in a different way. So what we have in Africa and what we do not have. The players of any market is these players. So we have universities. We do not have government, non-profit organizations. Governments governments in Africa are not aware yet about the importance of quantum computing. So we need awareness. They have a lot of problems. So they need to get the message about quantum computing, and of course they will support quickly. For example, in Egypt, we got 9 grants from the government, 9 grants to sign up the Science Up grants. So you can do this in your countries. We have public companies. We don't have public companies. Maybe we have startup companies like OneQuantum Africa, like the Center of Excellence in Egypt. But Center of Excellence didn't start its activity yet. It is under establishment. And the most important player is the market. So if you establish your own company, but no market, so from where you are going to get the salaries for the workers you have in your company. So we have to make awareness about the market to show them the importance of the quantum computing. And I believe if quantum computing itself is not you cannot go and buy a full system to manage your institution, for example, using quantum computer, but actually quantum cryptography are there. So they will try to start to understand the importance of quantum computing using a well-established technology, which is quantum cryptography and quantum key distribution. So we can start from there. The technology is not that hard. Actually, I had 2 graduation projects how to build this quantum key distribution. The student reach in 8 months, 9 months, maybe 80% efficiency. It's not it is not that good, but it is only 8 months effort. So you can establish actually companies. We can build the technology of quantum key distribution using the current technologies we have in our universities. The challenges we have in Africa, one is the diversity. Yes, we have many people working in quantum computing, but they are not working on the same topic. So we have to narrow the areas between people, and this can be done using meetings like this. And this is actually one of the aims of our Hypatia series, to discuss research so people can know and understand what they are doing and start a cooperation. So this diversity should be organized somehow with the people. Of course, we have lack of funds in Europe or in the US with hundreds of millions now, I think. We don't have that numbers yet, but I think we can apply for funds. For example, we applied for funds here in Egypt, and they give us 9 projects, not big number, and we will use it to buy equipments and research tools. But we can work on that. We have many funding bodies which can help in this. The dissemination is very important. The awareness is very important, and it can be done in much easier way because of COVID-19. So we can overcome these challenges using online meetings. So online meetings does not cost that much, but it helps a lot to deliver the message. We have this organized effort in many different ways, actually, because everyone is trying to work, but in different directions. So we have actually to organize our effort, organize what we want to do. For example, the countries that have very good groups, these groups can work towards an aim to help other countries which don't know anything about quantum computing to disseminate this science. I think I finished my talk, and I hope to see many groups on the map very soon. It is not that much. You can just go register for free on Quantiki and have your own website and have your own Facebook page and start to appear on the map to the globe. So I'm done, Mr. Fry. If you anyone has any question, I will be happy.
Thank you very much, Professor Ahmed Younes. Beautiful presentation, and this is the reason why I was bothering you to make this happen.
No, thank you very much.
Look at the number of people who just been angry.
Thank you very much. Thank you very much. Actually, I hope it be in a day where I can deliver the message in a better way. So what I'm.
No, that's okay. You did very well. Exceeded expectations as usual.
Thank you
So
very much.
as I perhaps wait for questions from the floor, I was going to say, so OneQuantum Africa would fall under your non-governmental organizations. It is structured that way to be a place where, you know, we remove this commercial interest and just allow people to collaborate.
Hello, Dr. Farai. Hello, Dr. Ahmed. Please answer my question, Dr. Ahmed, please.
It's okay. We'll give you the floor, Abdel. That's okay.
Okay, thank you.
So I was saying, so OneQuantum Africa is more of a community platform. But however, in Africa now we have got startups like Wayete Quantum Technologies that supported our summit, is a startup that is coming out of Stealth, which is really focused on the things that you were mentioning. And you'll be hearing more as well about it. It is structured to help commercialize the technology in the continent. You have conversations with the people in government, in the corporate environment, so that they learn about quantum, and also do a needs assessment of what processes are really there in industry which can benefit from quantum technologies, and then map those needs to the spectrum of quantum solutions we have in the space to see which could be the best partners, and if ever there's any need of hand-holding to deliver quantum value from quantum technologies, then we also do that. So there's a lot of exciting things that are happening that will also improve our image in terms of getting Africa on the map and having startups in Africa on the map.
This is very good, Farai, but to be visible is very important. For example, I would like to see one day in this panel jobs in Africa.
For sure.
That's actually, if you check these jobs, there are many tens of jobs in quantum computing in US, Canada, Asia, and Europe. And actually, if you check the titles, I hope no one apply for these jobs. We don't want to lose any expert from Africa. We want jobs in Africa. But actually, all these jobs are similar to the computer science jobs, the normal computer science job, software developer, system analyst, but quantum system analyst, quantum software developer, quantum data scientist, quantum program project manager. These are the same titles we used to use in computer science industry, but it is now quantum jobs. So I hope we have, actually, there are plenty of jobs they are seeking for people, and you can apply this Honeywell. I think this is one of your sponsors. They have many jobs in quantum computing. Don't apply for it. Stick with your job in Africa. And so you can find many jobs in quantum computing all over the world. But I checked this, none in Africa yet. So
and that's going to change.
Yes,
that's going to change. We're working very hard to change that.
Fast. Yes.
That's okay, Prof. Okay, so thank you. Abdelali, yes, you can come through and ask Prof your question. Hello, Abdelali, you wanted to ask the question. You can unmute yourself and ask the question. Thank you. So I'm not sure if you can hear me.
I think he unmuted himself, but I'm not sure.
Let me ask him to unmute and get him to come through. But he doesn't seem to be responding. Anyway, do we have any other questions or any comments, any suggestions? This is our platform to make this conversation go forward. So we would like to hear from you. We want to hear about what you are thinking, and we want you to feel like you belong here. So we are in the room together with you. So we don't want these ones to be more like webinars. We want them to be more discussions. The professor was just giving us a foundation to be able to, you know, to discuss and move this forward. But I guess you may have said everything else clearly, that there are no questions. I will come back to you and ask one of the interesting questions that I always get, and I know I have asked you this before on some direct conversations, but I would want you to answer this perhaps on a more public platform like this one. So we have got challenges. For example, I'm in Zimbabwe. Then you go to universities, and your university staff, the people who are in charge of the departments, may not be paying attention to quantum technologies, and they own this turf. And what's the best approach to engage people in academia already if our leading researchers are not involved, but we see that students have appetite to learn quantum and we have them in the community, but at the university level, they can't talk to anybody who is paying attention to developments in quantum tech? What could be the best approach to make it easy for people in academia to start thinking about quantum in some way? Perhaps a very respectful, strategic way of getting this conversation to happen.
Let me show you something. You don't go because you are not involved in academia, Mr. Farai, right?
Yes, I'm not involved. Yes.
Okay. But you can find, for example, using these slides, maybe you can have a meeting. I tell you, there are authors working on quantum computing in the academia. So actually, these are the best people to speak with because they are already interested. They are already doing work, right? And because they are from the academia, from inside the universities, they can disseminate the research inside the university. Their sound will be people in the university will can discuss with each other. So if you go, for example, to someone in the university, to the head of the university, and you speak to with him about quantum computing, he will not listen, right? But if there is a doctor from the university, speak with him, he will listen. So actually using this, for example, this slide, for example, you can know which one. And I think we had this meeting, and I showed you people in your country working in some topics, right? So go and speak with these people, tell them what you are doing. They will be immediately interested in what you are doing because they understand the importance, and they will help you to reach to the decision makers, and so the university will support you. This is the first step, the best step to take for this.
Thank you very much. I think that's very clear. Let me see if we've got questions in the chat.
I think there are questions in the chat.
Yes. So yes, Mark, thank you, Mark, for joining. So Mark says, how do networks like AIMS, Arua, OneQuantum Africa, and IBM, etc. help to grow a network in quantum computing research and then maybe startups in Africa?
Sorry, I didn't get the question.
How do networks like AIMS, Arua, OneQuantum Africa, where we are, like the initiative that was done by IBM, help to grow a network in quantum computing research and then maybe support the development of startups in the continent?
To organize their work. One of the challenges we have is disorganized effort. Yes, if we have aim, what we are trying to find, do we have a big aim to reach in? Do we have a plan what we want to do? Startup companies will not work in Africa unless we have market. Market is not necessary in Africa, right? The customer who is going to pay the salaries for the worker is not necessary in Africa. For example, India is selling software to all over the world. They are not selling software to India itself, right? So if we show build expert enough in quantum technology, we can find market, because I think we have cheaper workers in Africa, and sometimes much better. So we can compete with the companies in Europe or US in terms of the costs, right? So if we have good trainees, that's why we decided to have our own professional master in quantum computing, because it's very good to have these training sessions, workshop sessions over 1 week, or example. Sorry. But to work as an expert, you must have a certificate. You must have a full training to do this. So I think we need to have effort to have a well-trained expert in quantum computing, and we start to establish our startup companies and try to find. Let me ask you, for example, these companies that are publishing all these jobs, what are they selling? Do you know? I'm asking Mark, or ask you, Mr. Farai. Do you know what they are selling?
I don't know what they are selling.
We have to know that this is the question. This is the answer, which is actually we are not going anywhere. We have to know what are their products, and we have to go check their website, check what they are doing, so to see what we can do. Can we do better in this product? So, and we try to disseminate ourselves as a good competitor if we have experts. So to have startup companies, you have to know the product. You have to know the market. You have to you have to have your own human resources qualified enough to compete in the market.
Okay, thank you very much for that. I don't know, Mark, we wanted to add your voice to it. Thank you.
Oh, thank you. Yeah, thank you for the feedback. I'm just curious. I'm in Germany. I just recently moved to Germany, and yes, I agree with you. Everybody's selling software services and consulting services mostly at the moment. There's hardly anybody doing even hardware in Europe. I think there are 2 initiatives here. I actually just recently asked my team lead. And so it's very, very interesting, the dynamics I see. I just came from the US, and Farai kindly invited me to this meetup and his group. And so I'm kind of trying to see similarities and comparisons. But yes, I agree. The focus has to be on how can you bring yourself in and contribute to the field. And I think software services consulting it's just brain power. Anybody can do that. You just have to come up with the right use cases. And I think there were some good discussions also around that at OneQuantum Africa at the summit about agri-tech and other possibilities. So thank you for your overview and your response. That's very, very helpful for me to also understand the playing field.
Thank you very much. Thank you.
Okay, thank you, Mark. Perhaps one last one, if I don't have anything else from the floor. In summary, what's your framework for building a quantum competent workforce in Africa? How does that look like?
Sorry?
I was saying in summary, what is your view or your proposed framework for building a competent workforce in Africa? How does that look like?
Actually, our plan in a group, we are researcher in the first place. So we focus on research, and we try to disseminate the science itself in the neighborhood. So we try to produce experts who can compete in the market. That's why we are having this professional master in quantum computing in Egypt, in Alexandria University. And we try to reach to the lower level. For example, our plan in Q Egypt, when it starts, is to reach to the undergraduate students and maybe the high school students. This will increase the awareness of the field itself, and we have generations which can think in a quantum way. Because this kid will understand what's quantum computing, and actually his parents will know as well. So this will increase the awareness and make it not strange when people hear the word quantum. Usually they get scared. Wow, quantum! This word is weird usually. But people should understand that it is a product. It's just a new technology which you can use and which you can get benefits, a lot of benefits from it.
Thank you very much for that, because I think it's very important, and there may be need for all of us to learn how to do that, replicate and be better perhaps from what you're doing. But I guess that is the idea, to build a society that is just aware of what quantum technologies are for a start. And for those who can, take it further, also, get those opportunities to develop. I think with that, thank you very much, Professor Ahmed. I really appreciate it.
All right.
Yes, Abdul, you can come through and let's conclude with you. Thanks.
Yes, thank you very much. I just had some problems, some issues with my microphone, so I couldn't talk earlier. So what I was going to, to add on is, first, I would like to thank Professor Ahmed for this amazing talk. He touched.
Thank you very much.
Yeah, he touched a lot of important takeaways that we should really focus on after this talk. I always have been looking up to the Egyptian education. So
thank you very much.
Yes. So my commentary is regarding the disorganized effort. This actually, if you remember, Farai, this actually raises one of the previous questions that was raised in one of our previous meetings, is that like what kind of, or how we can really make the communities believe in their countries, in our local countries here in Africa, to believe in the communities, to believe in the future, to believe the future ecosystem, the future startups that will be here in Africa. What kind of beliefs that we should really focus on? I think I'm going to mention a word here, which is doping the quantum education into the already existing curricula in the current courses in universities. The word doping, a lot of the electric engineers actually familiar with it, which is doping some charges into other devices. So I believe in doping the quantum education in each major. As for my major is telecommunications. Like we should focus on what are the use cases for quantum in telecommunications, and maybe add take some maybe some elective course and just add some quantum to that curriculum course. Just step by step, doping quantum education into the already existing curricula in the universities will actually will build a community, and eventually,
hello,
like Harry.
Hello?
Yes,
Dr.
Yes,
Ahmed Younes?
Yes, Abdulali, perhaps Abdul, let him go ahead. Yes, you can go ahead.
Yeah.
Please, I have a question to Dr. Ahmed Younes. I direct message him, but I didn't get answer from him yet.
That's okay. You can ask.
What's the question?
See direct message in the chat.
Maybe that came direct to you, Professor.
Do you plan? I see. It's the first message. Do you plan for a startup company on quantum computing technology in Egypt or any other African country? Actually, we already have like small. It's not a formal company, but this center of excellence. It's not our plan now to sell products. But I think our mission is to educate people.
I'm not talking about buying or selling products, but how to build the quantum circuit, quantum device in the lab and test it and program it
I see. I see your.
It is very hard for us. We don't have the technology to fabricate even a transistor. So how to fabricate a quantum device? I'm just asking. I'm from Tunisia. I'm just asking. I know all.
Okay, yeah, I understand.
I have a great idea about this.
I understand your question, but actually, I'm not the correct person to answer this question because I have computer science background. So we are working theoretically, programming. If you see this a key component of the computer system, we are working on the higher level.
Yes, I'm with you, but we don't need to just to work on the top level. We have to work on the hard level.
Yes,
it's the key of the key technology of the quantum computing. The quantum device, the quantum circuit, the quantum gates, etc.
I agree with you, but my belief, I'm not sure if my answer is correct or not, but my belief, because there are many quantum computers appear on the market now, is that the technology is not that hard. It is there because superconducting qubit, especially if we have enough funds,
even using silicon photonics also.
For example,
like global foundries
yes,
are there for this
so
technology.
I don't think it is that hard to build a quantum computer. Otherwise, why we have so many quantum computers out there? You can use using the cloud now. If it is hard, for example, like the electronic microprocessor, it is really expensive, really hard technology. But I don't think it is hard. And I believe, and I checked that we have many experts in this field in Africa. So we just lack of fund and organization.
Yes, thank you, and thank you for your representation. And I am very happy to participate in this event. And thank you.
Thank you very much for your questions. Thank you.
Okay, thank you very much, Prof. We
So,
took long.
I
Yes.
believe we have. I can't find him. I think he left. The guy who spoke before, Abdul Farji.
Umak.
We interrupted him.
Abdul, Malek. Yes, Malek. Malek, can you quickly come and conclude so that we can end the meeting?
I think he left the meeting. He's not there.
Yeah, sure. I'm still here, Professor. Yeah, I was just mentioning, you know.
Yeah, because
briefly.
we were interrupted, so I'd like to continue your comment. Please continue your comment.
Yeah, I'm almost done, but in brief, my commentary for you is how can we really make intersect the quantum education within the already existing fields or the related fields in for quantum computing and quantum technology.
Actually, I'm not sure if you because I said that in Egypt we started with seminars until people understand the importance in Alexandria University. I mean, that's what we did for a few years since 2004. I got my PhD in 2004. When I returned back from the UK, I start to give sessions about quantum computing until people understand the importance. So then I suggested an elective course in quantum computing in the PhD level. I started from the top. Don't start from the undergraduate. Never start from the undergraduate. Start from the top because the ground is much bigger in the postgraduate level. New ideas can be accepted easily. So after a few years, we have started to have PhD holders. I suggest a course in the master level. So after that, we have two courses, master level and PhD level. After a few years, 2 or 3 years, when you have master students, awarded degrees in master students, I start working with the graduation projects of the undergraduate. So a couple of years, I'm sure that undergraduate students can understand the concept. I understand their questions because the questions are different on the different level. Now we have a course on the final year undergraduate, and course in the master level, and course in the PhD level. And finally, we have a full master in quantum computing. So you have to go from top to bottom, go from PhD to master to graduation to undergraduate, and that's it. I think this answers the question.
Okay, thank you very much.
Okay, thank you very much for the meeting, and thank you very much for the engagement and for this beautiful discussion. Unfortunately, we have come to the end of it. We've got a few minutes for those who have time. We have a link that we have posted for a cocktail that just allows people to come together, you know, one-on-one and discuss and explore opportunities for collaboration and, you know, take these relationships and conversations further. So if you've got time, feel free to jump on it. I think I shared the link. I'll try to share it one more time to everyone. So if you have time, I think we left with about 20 minutes or so we can quickly just have that running. And yeah, looking forward to meeting you guys next week, where we've got Alexandra Pritov from Russia to share also about the Russia quantum tech scene and what they are seeing from there, and any opportunities for collaboration, because international partners are also very important as we go on this journey, so that we learn about what is happening in their countries, things that we can adopt and those that we can adapt. And you know, like what Professor Ahmed was referring to, that we need to understand what companies are providing, so that we pick our areas of competence and areas we have got a competitive advantage, and we develop that way accordingly. So yeah, thank you very much, Prof. Thank you very much, everyone, for joining. I hope you had time to get the cocktail link in case we still have got a bit of time. So let's meet over there, and good night, good morning, good day, wherever you are. And thank you very much for the support. I really appreciate it. All right.